Hi guys, welcome to this introduction about CEPH. During this session, we will talk about the history of CEPH. Also, we will talk about the different characteristics that surrounding these solutions, which are the scalability, the reliability, and after that, we will talk about the different components of CEPH and its demands. Okay, about the history. Let's say that it has been developed in 1927 by Mr. Sager Whale. Okay, and after that he worked better in this solution, and on the 2012 he has he founded a new company in order to give a support on this solution, but the solution remains free. Okay, and in 2014, the company Red Hat has bought this intake, and now Mr. Sager Whale works for Red Hat, but the solution remains free. Okay. What is CEPH? CEPH is simply a software for the storage, okay, which is open source, and this software storage has been designated or developed originally to run around a commodity server. What does mean commodity hardware or server? This means that any types of constructor can be used in order to receive this software. Okay, so you can deploy this software or in any kind of server, and you can make your cluster by this way. And this cluster will need, of course, some hard drives. So which any type of hard drive, SSD, NVMe, or mechanical hard drive can be used as a storage backend in your cluster. Okay, and another thing, particularity of CEPH cluster is that it can, once this one has been built regularly, it can give to your infrastructure or your clients three types of storage: a file storage, an object storage, or also a block storage. So those three types of storage can be provisioned by the CEPH. Okay, it's fabulous, and it is a wonderful tool. So you can try to use it in your infrastructure, and you have, depending on your need of your client or your company, you can answer these three types of storage from your services. Okay. After this definition, let's talk about the one of two characteristics of CEPH, which is the reliability. For the reliability, we have to know that we can deploy CEPH with no single point of failure. That's a major characteristic of this component. You can deploy CEPH with no single point of failure. By this way, if your infrastructure suffers from a node which is not working very well, you can continue to have your activity working with no interruption of services. And another particularity of things that have been implemented in this cluster of service is two types of data durability, which has been performed by two types of coding or replication data. It's the hierarchy coding, and it is also the replication of data. The replication of data is simply your copy or any data which has been set to this cluster has been just duplicated in order to ensure the data durability inside your cluster. We have also, beside the replication, we have the erasure coding, which is simply your data will be just break into some chunks and spread across all your cluster. Okay. Another point is no interruption of services that you have when you try to perform a maintenance or any adding of a new hard drive or node inside your cluster. This solution has been designed to have no interruption of services during this kind of operation. You can extend your cluster, you can remove some nodes and some hard drive or some component of your infrastructure, and your system will not suffer from an interruption of services. Of course, you can suffer if you remove some major component nodes. This stuff, your system can suffer from performance, but no single point of failure, no interruption of services, no data losing in your cluster. A very important point. Okay, and another point that you have to know is that the data that are being stored inside your cluster is the data that you will retrieve. Okay. Now let's talk about the scalability, which is another characteristic of this cluster of software. Concerning the scalability, this solution is very elastic. That means that you can shrink your cluster by remove a component. You can also enhance or let grow your cluster by add new nodes. And this solution has been perfectly designed for this behavior from your company that you need to grow or shrink your cluster. Okay, and on the scalability point, we have this. Your cluster can scale out or scale in. Okay, to scale in by just add new component for regarding CPU run, just to enhance of the performance of one node or other nodes. Okay, so by this way you are going to scale in or in your cluster. And another scalability characteristic is the scale out. You can decide to add a new node to your cluster in order to just increase it. Okay, let's say that you want to add a new server in your cluster, so your cluster will perfectly support this action. Okay, and you can also want to add new hard driver to enhance or increase your capacity of your cluster. So the solution will no worry about that action. Okay. And another point that you have to keep or to know is the fact that you can have multiple sites across different areas, and both sites can be in replication or mirroring. Okay, like disaster recovery points, you can perfectly deploy this kind of solution inside for your company. Okay. So after talking about the scalability and the reliability, we'll deep dive on the Ceph daemon and nodes. Let's talk now about the different Ceph components. We are about to talk about the first one, which is the RADOS. RADOS means Reliable Autonomic Distributed Object Store. This layer is involved to managing the storage of any data inside your cluster. It's a major component inside the Ceph cluster. Okay, so by this layer, you can have access to your cluster for store with different data. And any data has been identified by two criteria, which are the object and its identifier. RADOS gave 3 ways to be accessible, and these 3 ways are the different types of backend storage that you can have from your site. The first way has an object gateway. Another one is the CEPH or file systems, okay, storage, and you have also the RADOS block device, okay, for the block device, for example, provisioning block device for the virtual machine, okay. Another way that you can have access, by which you can have access to RADOS is LibRados. LibRados is simply a library that any application can embed inside in order to be able to reach a Ceph cluster to retrieve or store data inside. Okay, very important librators. Okay, so you don't need for you are not obliged to have a virtual machine and anyone else to have access to a self cluster. If your application can embed a library which is librators, which library can be based on C# or Java or Python, so on, you can embed this library, and by this way you will be able to ratio the Redis layer. Okay. Let's show you a bit architecture of a self cluster, and you have a better view of how those components interact with each other. In this architecture, you can see the layer of for the client that can reach the self cluster through the three types of backend storage, which are the block storage, the file system for CEPH. We have also the last one with the Redis gateway for the object access to the cluster. Okay, it's not represented there, but you have also the librators that can be directly reached by any application that implement this library. Okay. By this way, you can have access to the Redis layer. Okay. Now, let's talk about another component, a major component of Ceph, which is Crash. Crash is an algorithm that has been implemented on the Ceph. It's responsible to have it's responsible to store the data. Okay, it is this algorithm for some parameter. Okay, so by executing this algorithm Crash, we will be able the cluster, the node of the cluster will be able to have the thing that we call the map, Crash map. This Crash map is simply a logical representation of your infrastructure inside your cluster. Okay, and after the Crash map, which is a one parameter, we have also the parameter which is designated how you want to store your data inside your cluster. For example, this how you want to store your data is designated by the failure domain. A failure domain is simply where at which level where you want your data to be stored. Okay, this level is mapped to your Crash map. For example, when you store a data, it's inside the hard drive. Okay, this hard drive represents the first level. Another level is simply your host, also representing your second level. And any host is inside a rack, and a rack is inside a room, inside of within a room of data center. You have some rooms. Okay, and so you have. Within the rooms, you can have many rows. Okay, so you can have, for example, 3 rows inside the room, and this room is inside the data center. By this way, you can achieve some level of how your data center or your logic, the logical representation of your data center inside of your Crash map. Okay, you can say that for this type of object, I want that of the data has to be stored at the host level. For this other types of object, I want that of the data has to store at the OSD level. Okay. For example, for the data that has been stored at host level, if one host has been lost by power outage of any maintenance or issue that one section has been done inside the data center. If this host has been lost, you don't have to worry, because it's only one copy of data has been stored, which has been stored inside this host. Okay, so other copy can be retrieved on another host inside your data center. Okay, it is very wonderful and flexible solution that you can build out by this way. Okay, now let's talk about the Ceph daemon, the major Ceph daemon that we can have inside your cluster. We have three daemons which are the Ceph monitor, Ceph Manager, and the Ceph OSD. Okay, so the major monitor daemons that you can have inside the Ceph cluster. The Ceph monitor is involved to maintain the cluster health. Okay, it also involved to manage the detoxification across the cluster. The Ceph Manager is involved to collect any data about the health of your cluster. Those data can be enhanced or can be shown over the dashboard. Okay, so the dashboard, the Ceph dashboard has been handled by the Ceph Monitor daemon, Ceph Manager daemon. Okay, and another point is the Ceph OSD daemon. The Ceph OSD daemon have a biggest part of job also inside your cluster because it is involved to store effectively the data inside your cluster. It also manages the monitoring of it. All the OSDs are in the monitoring inside. Okay, so each OSD take care about another OSD. So by this way, if any OSD has been crashed down, this another OSD will report this action to the monitor. Okay, so it is the OSD that take care about another OSD. Okay, so by this way we can have a fully cluster monitoring by these three daemons. Okay, so we talk about a lot about the Ceph monitor and OSD, and we stop here today. And for the next lesson, we will talk about the different nodes that we have inside the Ceph cluster, and also we'll talk about what are the different prerequisites that we have to put in place to build a high performance cluster for your company. Okay, thank you very much and have a good one, and see you for the next session. Bye.